Hello there and welcome to Lower 6th Further Maths Pure Core 1, June 2011. Let's get started on question 2 now. So for part A is the matrix 1, root 2 minus 1, and it asks you to find A squared. So A squared refers to matrix A times matrix A again. So I could do all of this in the calculator, however I feel that probably it's going to save me some time if I just do it manually. So remember, to multiply matrices you go across the row and down the column in the corresponding cells. So 1 times 1 is 1, root 2 times root 2 is 2, 1 add the 2 gives me 3. 1 times root 2, oh, got minuses here. 1 times root 2 times root 2 times minus 1 is minus root 2. Root 2 take away root 2 is 0. Root 2 times 1 here is root 2. Take away 1 times root 2 is 0 again. And root 2 times root 2 is 2. Minus 1 times minus 1 is 1. So 2 add the 1 gives me 3. So that's the answer to part AI. Part AII, describe the geometric transformation of A squared. So what this is it's an enlargement. This should be one that you just recognize immediately. Enlargement scale factor of 3, and it has to be from the point 0, 0. So that's AII. Part B looks for you to describe the geometric transformation of this 3 by 3 matrix. Now this wasn't in FP1, this is new to Pure Core 1. So the way that I deal with these questions is I look for which letter is already in the correct place according to its x, y or z variables. The y variable here looks to be in the right place. So I'll delete that row and I'll delete that column. And what I'm left with is 0, 1, minus 1, 0 on the xz plane. Now, what I do now is I look for what happens if I apply this matrix to the 1, 0, 0, 1 matrix. This vector here is 1, 0, and this vector here is 0, 1. So the first vector here is this one here, the second vector here goes in here. This nicely gives us the identity matrix, so I get exactly the same answer as I do at the front. So this matrix has moved these 2 points. Let's give this one a square and this one a triangle, to the coordinates. Well, the 1, 0 is going to move to 0, minus 1. So that's going to move it down here. So the triangle has moved down here, and the square has moved to 1, 0. So the square has moved to here. So I can clearly see that what's happened here is there's been a rotation around the point 0, 0, 90 degrees anti-clockwise. So that's what I'll need to write. Rotation 90 degrees anti-clockwise. Now, if we remember back to what sort of plane we had here, we had the XZ plane. So what was the dimension left out there? It was the Y dimension. So it's going to be a rotation 90 degrees anti-clockwise around the y-axis. The y-axis is the one that's nice and stays where it is. The x and the z one rotate 90 degrees anti-clockwise around it. Moving on to the last question, given that k plus 1, 12, k and 9 are constant values, find the values for which k makes the matrix C singular. Now, for a singular matrix, this means that it doesn't have an inverse, and when it doesn't have an inverse, then the determinant of the matrix is 0. So I've just got to find which values for k will make this matrix have a determinant of 0. So the way that I work out the determinant of a matrix is to do the leading diagonal multiplied together, take away the other two values multiplied together. So 9 lots of k plus 1, take away 12k equals 0. Simplifying this, 9k plus 9 minus 12k equals 0. This will make 9 equals 3k, so k equals 3. And that's the value for k such that the matrix C is singular. 3 marks for that part, 10 marks in total for all three of those parts.